Morning everyone. Today we are here for the solution of ODISHA NEET paper. Okay, in the first question of physics section, in the first question is the U-tube shown in the figure. In the left column there is water, in the right column there is some other fluid, some oil. The height from the bottom of the water and air column are given in the picture. We have to determine the density of the oil. Okay, so you see at this portion they both have same pressure, right? Otherwise the wall will not be at rest. The separation wall would have moved. So at these 2 points they have equal pressure. So here the pressures were atmospheric. So this pressure difference due to this height will be pressure difference due to this height, which means rho naught, that is the density of water, times this height 15 is equal to the rho which we want to determine times this height 20. Of course there both sides there is g which cancels out. So rho will be equal to 15 by 20 times rho naught. Rho naught means density of water, which is 1000 kg per meter cube. So after doing this you are getting 750 kg per meter cube. So you are getting, our correct option is option number 1. Okay, for the next one, there is a rectangular pond of surface area A is containing water and is located in a region where the outside air temperature is at a steady state value minus 26 degrees centigrade. That means the water will freeze to ice and the thickness of the frozen ice will increase with time, right? So at any moment the picture is like this. Let's say we already got x depth of ice, okay, and the outside temperature is minus 26 degrees centigrade. Okay, now the thermal conductivity of the ice is K, specific latent heat of fusion is L. We have to determine the rate of increase of the thickness of layer at this instant. Okay, so here the ice is forming again, and let's say in dt time the thickness is getting increased by an amount dx. So here the temperature is 0 degrees centigrade. So the latent heat which the water leaves, the water rejects and become ice, is equal to the rate of heat conduction through it, right? So the rate of heat conduction through it is equal to Ka, temperature difference, that is 0 minus 26 divided by x. Okay, so that is the heat conducted per unit time. Okay, and now see, in dt time dx thickness of water becomes ice, so it rejects latent heat, and that amount is equal to the mass of this element, which is equal to area times dx, that means this volume of this water which has just become ice in dt time, times the density rho, that is the mass, latent heat is L. So that is the total heat needed to convert this dx thickness of water into ice, and it happens in dt time. So the rate of heat is dx dt divided by dt. So these two are equal. Okay, so now if you equate them, you are getting that dx dt is equal to k times 26 divided by rho lx, and you have to determine what is dx dt. Okay, so you are getting option number 2 is correct. An LED is constructed from a p-n junction diode using gallium arsenide. The energy gap is given. The wavelength of the light emitted will be equal to, okay, pretty straightforward question. So Hc by lambda will be equal to the required energy gap, delta Eg. So from here you have to determine what is lambda. So lambda is simply equal to Hc divided by that energy gap, and if you put the values and calculate, you will get it is 654 nanometers. Okay, so our option number 1 is correct. Okay, this circuit, okay, just consider the input and output here. Suppose put value of A is 0, value of B is 0, that means the circuit is like this. The current will flow like this, the current will flow this path, then like this, then up to this. So the bulb will glow. So you will get output is equal to 1. Okay, now make A is equal to 1. So this part will become short circuit. So the current will only flow via this path, so the bulb will not glow. So output will be 0. Similarly, if you put this disconnected but this one connected, then again the same thing. It is a short circuit, so the bulb will not glow. So it is 1, hence the answer is 0. And if both of them are short circuit, again the same case, the bulb will not glow. So what you are getting, The value of gamma for hydrogen, helium and another ideal diatomic gas whose molecules are not rigid but have an additional vibrational mode. Okay, so for X there is also vibrational degree of freedom. Okay, they are respectively equal to. Okay, so it's a pretty straightforward question. So our law is gamma is equal to 1 plus 2 by F. So for hydrogen, the degree of freedom is 5 diatomic, so it will be 7 by 5. For helium, it is monoatomic, so it is 1 plus 2 by 3, so it is 5 by 3. Clear? So for hydrogen it is 7 by 5, then for the next one it is 5 by 3. Let's see if this 2 gives us the answer. No, there is another one thing to check. So gamma of X is equal to 1 plus 2 by, now as there are additional vibrational modes, so 2 more degrees of freedom for vibration, vibrational potential and vibrational kinetic. So it will be 7, so 1 plus 2 by 7 means 9 by 7. So we are getting our option number 4 is correct. Two metal spheres, one of radius r and the other of radius 2 are respectively have the same surface charge density. They are brought in contact and separated. What will be the new surface charge densities on them? Okay, so when you contact them and separate them, the potential remains same, becomes same. That means if one get charge q1, then q1 by r is equal to q2 by 2r. And of course, which is equal to q1 plus q2 by 3r by component and divide into. So from here you can determine q1, which will be equal to 1/3 of q1 plus q2, and of course you can determine q2, which will be equal to 2/3 of the total charge. Okay, so if you determine this, you can determine what is sigma 1 and sigma 2. Let's say the total charge, I am writing it by q. The total charge q is equal to, they had both same charge density sigma, so sigma times the total area of both. So the radius r has area 4 pi r square and the radius 2r has area 4 pi times 2r whole square, that means 16 pi r square. So the total q was equal to 20 pi sigma r square, right? So q1 is equal to 20 by 3 pi sigma r squared, q2 is equal to 40 by 3 pi sigma r squared. Okay, so you got q1 and q2. Now your job is to find what is sigma 1 and sigma 2. So sigma 1 will be equal to q1 by the surface area, that means 4 pi r squared. Okay, so if you do that, you are getting it is equal to 5 by 3 sigma. Okay, quite easy calculation. And if you do sigma 2, that means q2 divided by 16 pi r square. So you are getting it is 5 by 6 sigma. So correct option, the sigma 1 is equal to 5 by 3 sigma, sigma 2 is equal to 5 by 6 sigma. So it's clear that option number 3 is the correct one. The distance covered by a particle undergoes a SHM in one time period. Okay, it's not asked what is the displacement. The displacement is of course 0 after a complete time period. It is asked what is the distance covered by the particle. Okay, let's take from any point. Let's say the mean position. The particle is starting from mean position. So it is plus a, x equal to plus a, it is x equal to minus a, and it is our mean position where the origin lies, x equal to 0. Okay, so a complete time period means the particle has gone from here, so it covers a distance, then again come back to mean position, another a distance, then go from mean position to the negative end, then again come back to the mean position. So this is the total complete time period, right? So it is covering, of course, 4a distance here. It's quite easy to see. So option number 3 is the correct one. A mass falls from a height h and its time of fall t is recorded in terms of time period t of a simple pendulum. On the surface of earth, it is found that t equal to 2t. Okay. So actually on the surface of earth, what happens? There is a value of g and there is a value of time period also, and the values are like this. So time of falling, that small t is equal to root under 2h by the g on surface of earth, and the time period is equal to 2 pi root under L by g. Okay. And it was found that small t equal to 2 times the time period. Now the entire setup is taken on the surface of another planet whose mass is half of the earth and radius is the same. So you have to check how g is changing there. Okay. So if you consider the change of g, so g prime now is equal to g, the mass is half gm by 2 divided by radius is the same. r square. That means it is equal to g by 2. So g changes by the amount g by 2. So the t prime, the falling time, will become root under 2t. T was equal to this, now put g equal to g by 2. The time period will be equal to 2 pi root under L by g. So it is also will be equal to L by g prime. So it is all equal to root under 2 capital T. So the relation will remain same. T prime will be equal to 2 capital T prime. Okay, so the same relation will remain valid. So our option number 3 is the correct one. Okay, now for the next one. Tuning fork with frequency 800 Hz produces resonance in a resonance column tube with upper end open and lower end closed by water surface. Successive resonances are observed at some lengths which are given. We have to determine the speed of sound in air. Okay, so from the first information, we are getting lambda by 2 is equal to 9.75, that is the length, plus x. Okay. Then successive resonance, as it is one end open, so next resonance is 3 times. So 3 times lambda by 2 is equal to 31.25 plus x. Okay, x is the length of the water. And then for the next resonance, 5 lambda by 2 is equal to 52.75 plus x. So these are the 3 informations given. So now we can solve for this, right? So if you solve for these 3, you will get that lambda is equal to 21.5 centimeter. Okay, and the frequency is given 800 Hz. So you can easily determine what is v. So velocity is equal to lambda times frequency. Just put lambda in proper unit, that means in meter unit. So you will get it will be 172 meter per second. So option 3 is the correct one. Okay, this is the question. We are unable to give you the proper answer. We will tell you how to do the problem, because the picture which you got of the question does not have this ratio in the information. Actually, see the question: an object flying in air with some velocity given suddenly breaks into 2 pieces. You can understand that it breaks into 2 pieces whose masses are in the ratio. There is the problem. You need the ratio. The smaller mass flies off with a velocity this. The velocity of the larger piece we have to determine. Okay, so we cannot do it exactly. We cannot get the answer because we don't know what is the ratio. It is missing in the print. Sorry, we are unable to provide you the exact option. So we are doing it in the algebraical way. How to solve this? The smaller mass fly with the velocity given. We have to determine the velocity of the larger piece. Let's say the 2 pieces whose mass are in the ratio 1:n. If this is the case, we can solve it. So let's say the smaller piece has mass m and the larger piece then of course has mass n times m, and the total piece unbroken were mass 1 plus n times m. So now the total momentum remains constant, right? So initially the total momentum was 1 plus n m times that velocity, which is 20I plus 25J minus 12K. That was the initial momentum, and in this thing momentum remain constant because in that very small moment of time there is no external impulse acting on it. You might argue that gravity is there, but okay, gravity is there, but in the small instance of time when it just breaks, just before breaking and just after breaking, the gravity does not have any significant impulse on it, right? So momentum will not significantly change. So this was the initial momentum, and the final momentum is equal to, for the smaller piece, m times the velocity, 100I cap plus 35J cap plus 8K cap, plus the larger mass in m times its velocity, which you have to determine v. So v is the unknown. So from this equation you can easily solve it vectorially in form of I, j and k. Okay, so that is the way to do it. We are again sorry to be unable to provide you the exact answer because we don't have this information what is n. Okay, we are going to the next one. The main scale of a vernier caliper has n divisions per centimeter. N divisions of the vernier scale coincide with n minus 1 division of main scale. We have to determine the least count of the vernier scale. Okay, now 1 division on the main scale is equal to 1 by n centimeter. It's given in the question. And 1 division on vernier scale is equal to n minus 1 by n times 1 by n. So now least count is equal to 1 main scale division minus 1 vernier scale division. So you are getting it 1 by n square. So the correct option is option number 2. A person traveling in a straight line moves with a constant velocity v1 for certain distance x and with a constant velocity v2 for next equal distance. The average velocity means total displacement divided by time taken. So let's say the total distance is 2x. So the first half x he covers with distance v1 with velocity v1. So now the average velocity is equal to distance by time. So total distance is 2x. For up to this, it is going with v1, then it is going with v2. So first x distance, the time taken is x by v1. The next x distance, time taken is x by v2. So it's quite clear that 2 by v average is equal to 1 by v1 plus 1 by v2 after cancelling x from numerator and denominator. So our option number 1 is the correct one. Assuming that the gravitational potential energy of an object at infinity is 0, the change in potential energy of an object of mass m when taken to a height h from the surface of earth is given by, okay, so when it was at the surface of earth, the potential energy of the system was minus gmm by r. This was the initial potential energy. And when it taken to height h, then the potential energy becomes minus gmm by r plus h. So the change in potential energy, that is final minus initial, is this. That means it is gmm times 1 by r minus 1 by r plus h. Okay, so clearly the answer is gmmh divided by r times r plus h. So option number 1 is the correct one. 1 gram of water of some given volume at 100 degrees centigrade is converted into steam at same temperature under normal atmospheric pressure. The volume of steam formed is given. If the specific latent heat of vaporization is 2256 joule per gram, please mind it, not joule per kg, the change in internal energy. Okay, so here work done we can easily determine. The work done is equal to 1671 is the final volume. Initial volume was 1, taking ideal gas, times, so this is the volume change, times the pressure. Okay, 10 to the power minus 6, because it was centimeter cube, we have to convert it into meter cube, that's a 10 to the power minus 6, and there is 10 to the power 5. So this is clearly 167 joule. 167.1, okay, 167 joule. Okay, now Q, the latent heat is given, it is equal to 2256 joule per gram. Okay, it was 1 gram, so 2256 joule. We have to determine change in internal energy. So now from thermodynamics first law, Q is equal to delta U plus W. So delta U is basically equal to Q minus W. So you can simply put the values and you can determine it is equal to 2089 joule. So our option number 1 is correct. Going to the next one. Angular width of the central maxima in the front of a diffraction for a given lambda is theta naught. When the same slit is illuminated by another monochromatic light, the angular width decreases by 30%, the wavelength of this light. Okay, so angular width theta naught is equal to 2 lambda by a. It is given. And for the next case, 0.7 decreases by 30%, so it becomes 70%. 0.7 theta naught is equal to the new lambda, 2 lambda prime by a. So clearly lambda prime is equal to 0.7 lambda, which is equal to, by putting the values, 4200 Armstrong. So option number 1 is correct. We are going to the next one. The work function of a photosensitive material is given. The longest wavelength of light that can cause photon emission from the substance. Okay, it's quite simple question. Just hc by lambda max, which we have to determine, is equal to the work function. So from here you can determine what is lambda max. So if you do the calculation, you will get, I'm not showing the calculative part, you can do it easily, it's an arithmetic. So it's equal to 310 nanometer. Okay. For the next one, a proton and alpha particle are accelerated from rest to the same energy in the de Broglie wavelength. Okay, so de Broglie wavelength is equal to h by p. So it is inversely proportional to 1 by p, and p is equal to root under 2m energy. That means p is linearly proportional to root under energy. So lambda will be inversely proportional to root under energy. Okay. So lambda of proton by lambda of alpha particle will be equal to root under, there is a mass of course 2me, sorry, the energy is same, so it will be in the ratio of root under mass. So root under m is there, the energy is same, need not write that. So this will be in the inverse ratio of root under mass. So mass of alpha particle by mass of proton, and of course this ratio is 4, so root under 4 is equal to 2. So the correct option is option number 4. The radius of the first permitted Bohr orbit for the electron in a hydrogen atom equals 0.51 Armstrong, and the ground state energy equals minus 13.6 electron volt. Okay, it's quite given information. If the electron is in the hydrogen atom is replaced by muon particle, charge same as electron and mass 207 mass of the electron, the first Bohr radius and ground state energy will be. Now we know that nth orbit radius is given by epsilon naught a square n square by pi square m, and energy in nth orbit, this is the thing you require here. It's a lot to remember, but there is no other option in this question. M divided by 8 pi epsilon naught a square. Okay, so by putting the values, for now move on, you can determine what is the radius and what is the energy. And if you put the values, you will get radius is equal to 2.56 into 10 to the power minus 3, and you get energy is equal to minus 2.8 kilo electron volt. So correct option is option number 2. The reading of an ideal voltmeter in the circuit shown. Okay, there's not much calculation required. It's quite easy. See, it's ideal voltmeter, so there is infinite resistance. So basically these two are open. You can consider the infinite resistance. So it is 50 ohm in series. It is also 50 ohm in series. So both 250 ohm in parallel give you total current. You don't need the total current, you can tell the branch current. So this branch current will be 2 by 50 ampere, and this branch current will also be 2 by 50 ampere. Okay, I'm just written it here, it should be in the uppercase. Okay, so let's say this point has potential 2 volt and this point has potential 0. You can assume it, no problem is there, because you need the difference. You can assume any potential, because potential value at some point is defined by us. It's not told you by laws of nature, right? Laws of nature just tells you by defining the potential that you can define the potential energy change. That's all. So 2 volt, then 20 ohm and 2 by 50 ampere. So the potential drop up to this point will be equal to 2 by 50 times 20. That means 4 by 5. That is the potential drop. So 2 minus 4 by 5 will be potential at this point, A point. Potential at A will be 2 minus 4 by 5. Similarly, if you determine potential at B, that will be equal to 2 minus 2 by 50 times 30. That means it will be equal to 2 minus 6 by 5. It is potential at V. Potential at B. So the voltmeter reading will be the magnitude of VA minus VB. So it will be 6 by 5 minus 4 by 5. So it will be equal to 2 by 5 volt. So 2 by 5 means 0.4. So as you see, our option number 3 is the correct one. The meter bridge shown is in balanced position with P by Q is equal to L1 by L2. Now if we interchange the position of galvanometer and the cell, will the bridge work? If yes, what will be the balance condition? Okay, it's a normal theory. We all know that if we interchange these two, nothing will change. The bridge will work, and of course P by Q will remain equal to L1 by L2. So option number 3 is the correct one. Relations amongst the three elements of Earth magnetic field, namely horizontal component H, vertical component B, and the deep angle delta. Okay, so we all know the picture. So this is the horizontal component BH. This is the vertical component BV. This is the net magnetic field, the resultant of them, and this angle is delta. Okay, so from here you can easily determine B is the total magnetic field. It is given BE is the total magnetic field. So of course you can say option number 1 is the correct one. So vertical component V is equal to B sin delta, and horizontal component H is equal to B cos delta. So option number 1 is the correct one. An object kept in a large room having air temperature of 25 degrees centigrade takes 12 minutes to cool from 80 to 70. The time taken to cool from the same object from 70 to 60 will be. Okay, so it's Newton's law of cooling approximation problem. So first it takes 12 minutes to cool from 80 to 70. So 80 minus 70 by 12 is equal to the constant alpha times the average value 80 plus 70 by 2 minus the ambient temperature 25. And that is the first equation. Now the second one, now it cools from 70 to 60. 70 minus 60 divided by the time we have to determine, let's say the time is t, is equal to alpha times the average temperature 70 plus 60 divided by 2 minus the ambient temperature 25. Now simply divide these two equations. You can determine what is t. Alpha will cancel out and you will get t is equal to 15 minutes. So our from this solution we can get that our option number 3 is the correct one. We are going to the next one. Two small spherical metal balls having equal masses are made from materials of densities rho 1 and rho 2, and rho 1 and rho 2 relation is given, and the radius is given. They are made to fall vertically in a viscous medium whose coefficient of viscosity equals eta and its density is 0.1 rho 2, the ratio of their terminal velocities. Okay, so the terminal velocity Vt is proportional to r square times rho minus rho of the liquid divided by eta. Okay, so now the first case terminal velocity divided by the second case terminal velocity is equal to, by simply putting the values, it's 1 square by 2 square, the radius ratio, times rho 1 minus 1 by 80 rho 1 divided by rho 1 by 8 minus rho 1 by 80. So if you do the calculation, you are getting terminal velocity of 1 by terminal velocity of 2 is equal to 79 by 36. So our option number 3 is the correct one. A particle starting from rest moves in a circle of radius r. It attains the velocity v0 in the nth round. Nth round means that already rotated by an angle 2 pi times n. Its angular acceleration will be. Okay, so now v square equal to 2a times distance. So 2a times distance is 2 pi n times r. Okay, is the tangential acceleration. So you are getting tangential acceleration is equal to v0 square by 4 pi r n. Now alpha angular acceleration is equal to 80 by r. So it is v0 square divided by 4 pi r square n. Okay, so our option number 2 is the correct one. A person standing on the floor of an elevator drops a coin. The coin reaches the floor in time t1 if the observed elevator is at rest, and in time t2 if the elevator is moving uniformly. Then, okay, I'll tell you two solutions. First is from general theory of relativity, special theory of relativity, but you know all those are principle that there is no difference between two inertial frames. Every experiment you conduct inside an inertial frame cannot tell you the difference between A inertial frame and B inertial frame. I mean, you cannot distinguish between rest and uniform motion by performing any experiment within that inertial frame. So you should not have different answer. The time will remain same. And if you want to do it mathematically, the thing is like that. When the elevator is at rest, there is nothing that is at rest. It's rest in your reference frame. Okay. And if you just drop the coin, so it is falling with zero initial velocity and g acceleration. Now if the elevator is moving with constant velocity, just look at the phenomena in the reference frame of the elevator. Then again the initial velocity is 0 and the acceleration is g. So the time taken will remain same. So t1 will be equal to t2. But I like the first explanation, of course. There is no difference between two inertial frames. They will remain same. A truck is stationary and has a bob suspended by a light string in a frame attached to the truck. The truck suddenly moves to the right with acceleration a. The pendulum will tilt by which angle? Equilibrium angle we need. Okay. So when it moves with acceleration a, it will tilt. Now we can solve it from reference frame of ground or from the truck. I am solving it from the reference frame of ground. So there is the force T and there is mg. And as the truck is moving with acceleration a, the bob will also moving with acceleration a, and the force condition is like this. There is T, there is mg, and this angle is theta, as this angle is theta. So it's quite easy. I have already solved it many times. Its acceleration is a. So T cos theta is equal to mg, and T sin theta is equal to ma. So dividing them, you are getting tan theta is equal to a by g, or theta equal to tan inverse a by g. Also option number 1 is the correct one. Okay, now for the next one, a body of mass m is kept on a rough horizontal surface. Horizontal force is applied on the body, but it doesn't move. The resultant of normal reaction and the frictional force acting on the body. So the mass m is kept on a rough horizontal surface. Horizontal force is applied on the body and the body doesn't move. So the net resultant of the forces is 0. So there are some other forces, which is N, and there is mg, and there is friction force. Now the resultant of normal reaction and the friction force we need to determine. So the resultant of normal reaction and friction force is equal to the magnitude is N square plus F squared. Now N here is equal to mg, and F here is less than equal to mu times N, that is mg. As it is static friction force, you cannot say what is the exact value. It is not given as the limiting friction case. So magnitude of F will simply be less than equal to mg times root under 1 plus mu squared. So option number 2 is the correct one. A particle of mass 5m at rest suddenly breaks on its own into 3 fragments. Of course, you already know the momentum will remain constant. 2 fragments of mass m, each moves along mutually perpendicular direction with speed v each. The energy released during the process. Okay, so the total momentum is 0 initially and it should remain finally also 0. So 2 fragments of mass m, each move along mutually perpendicular direction with speed v each. Let's say one is going along this direction, another is going along this direction. Let's say this direction is x and this is y. So the 2 fragments, they are going with momentum, one along this direction, one along this direction. The magnitude is same, the momentum vectors are different. So this momentum vector, let's say it is p1, this momentum vector let's say is p2, and there will be another momentum vector of the third one, which is p3. Okay, so p3 plus p1 plus p2 should be equal to 0. So p3 vector is equal to minus of p1 vector plus p2 vector. Now p1 vector is equal to m, velocity v I cap, and p2 vector is m v j cap. So p3 vector is equal to minus mv times I cap plus j cap. So the energy released during the process E is equal to the energy released during the explosion is the kinetic energy what it got. So it is equal to p1 square by 2m plus the mass of this particle was m, p2 square by 2m plus p3 square by 2 of its mass, which is equal to 3m because the total mass was 5m. Now you can simply have the calculation, right? You know the p1, p2, p3 values. So you do that, you will get it is 4 by 3 mv squared, which means our option number 3 is the correct one. An object of mass 500 gram initially at rest is acted upon by a variable force. So the x component varies with x in the manner in the graph shown. So force versus x is given. The velocity of the object at the point x equal to 8 meter and x equal to 12 meter would have the respective values. Okay, now we are using work energy theorem. Work done equal to change in kinetic energy. So work done means area under the graph. So basically our law is now this: area under the graph up to, let's say x equal to 8. So up to this area we have to calculate. It's quite easy. 2 rectangle summation area. Okay. Area under the graph up to x equal to 8. This will be equal to, up to x equal to 8. This will be equal to the change in kinetic energy. Okay. So it is half. Mass is 500 gram, that means half kg. It was initially at rest times v square. Okay. V at x equal to 8. Let's say it is v8. So you do the calculation. You can easily determine what is the area. It is 20 times 5 plus 10 times 3. So area under the graph up to this is equal to 20 times 5 plus 10 times 3, which is equal to 130. So you can determine V8 is equal to 22.8, almost equal to 23 meter per second. And similarly, if you want to determine up to x equal to 12, you have to take the total area up to x equal to 12. We are doing the same case again. So it is half times mass times V12 square is equal to, that area was 130 minus this area, it is 25 times 2 for the rectangular part, and then for the triangle part it is half times 5 by 2. It is negative area, that means now the force is in the opposite direction, so the speed is decreasing, plus 10 times 2, another rectangle. So from this calculation you will get, and this is equal to 97.5 after doing the calculation. I have already done the calculation, that's why I am telling you so rapidly. Don't think that I am doing it in an instant. So V12 is equal to 20.0 meter per second. So our correct option is option number 2 here. Okay, now we are going to our next problem. A solid cylinder of mass 2 kg and radius 50 cm rolls up an inclined plane of angle of inclination 30. The center of mass of the cylinder has speed given. The distance travelled by the cylinder on the inclined surface will be. Okay, here, so 3 by 4 mv square is equal to, as a solid cylinder, so the total kinetic energy is half mv squared plus half I omega squared, and cylinder I is equal to half mr square and omega is equal to v square by r square, omega square. So we are getting 3 by 4 mv square. I will do the calculation again. It is half mv squared plus half I is equal to half mr square times omega square is equal to v square by r square. So we are getting these things, 3 by 4 mv square. Okay. So this thing is equal to mgh. You want to determine what is h. Distance travelled by the cylinder on the inclined plane. H will give you height. The inclination angle is given. Then you can determine what is the distance travelled. So from here you are getting H max is equal to, this capital H is equal to, after doing this calculation, it is equal to 1.2 meter. So now this height you have got 1 by 2 meter. You want to determine this length. This angle is 30. So it is 2 times sin 30 is half. So the distance it will travel is equal to 1.2 times 2, that means 2.4 meters. So option number 3 is correct. We don't have sufficient information here. 200 and 100 respectively with average. I mean, the question part has been missing. So we are again sorry and unable to provide any solution. Basically the question pattern was like this, that the magnetic fields along two loop, you need the ratio. The number of turns is given, I think, respectively with average and anyway, it's a number of turns it was given. So same current I means, you know, the magnetic field at center, it is n times, n is the number of loop, mu naught I by 2r. So that will be the thing needed in this question, but the print is not clear for now, so we cannot provide you any clear solution of it. What is the answer? Again, unable to do this. Just I'm telling you, this is the way to do this problem. Okay, a straight conductor carrying current I splits into two parts as shown in the figure. The radius of the circular loop is r. The total magnetic field is the center of the loop. Now I1 and I2. I1 is giving the field in the direction into the page, and I2 is anti-clockwise, so it is giving the current in the direction outward from the page. Okay, I2 current is making angle. You can easily determine what is the I2 current making angle. It is 90, and I1 current is making this angle. Okay, now this is a direct theory, you all know. If any circular loop, you connect battery in any 2 points, then the magnetic field at center becomes always 0. You don't have to calculate it. You already know the answer. The answer is 0. So correct option, you have studied it in your syllabus. The option is 4. You don't have to calculate it totally. The two magnetic fields cancels out. For the next one, which current can be called AC? For C and D, amplitudes on positive and negative halves are different. Clear? As the amplitudes on positive and negative halves are the different, we cannot tell them. So our correct option is option number 2. A and B are the correct options. They are the perfect alternating currents. An equiconvex lens as power P, it is cut into two symmetrical halves by a plane containing the principal axis. The power of one part will be, okay, as it is cut by a plane containing the principal axis, that means the cut is like this. This kind of cut. This does not change the focal length because the power remains same. Okay, so correct option is option number 3. Because the power is equal to, just you can easily determine the total power of the two surfaces, mu2 minus mu1 by r, summation of these two terms. Now that is not changing because the radius of curvature has not changed. It would have changed if you cut it by like this, but this is not this kind of cut given in the question. So the power remains same or focal length remains same. In a Young double slit experiment, if there is no initial phase difference between the light from the two slits, the point on the screen corresponding to the fifth minimum has passed difference. Okay, so point on the screen corresponding to the fifth minimum, you have to determine the path difference there. Okay, for nth minimum, we know that the delta x path difference delta is equal to n plus half times lambda, 2n plus 1 into lambda by 2, same things. So for fifth minimum, we can determine what is the path difference. N is equal to 5, n is equal to 4 for the fifth minimum. So it is equal to 9 by 2 lambda. Okay, so our correct option is option number 2. A double convex lens has focal length given. The radius of curvature of one of the surfaces is double of the other. Find the radius, two radiuses, if the refractive index of the material of the lens is 1.5. Okay, so just I am using lens maker's formula. It's the 1.5 minus 1 times 1 by r plus 1 by 2r. This is equal to 1 by 25. So it's quite easy. You can determine r is equal to 18.75 from here. So correct option is 2, 18.75, and double of it, 37.5. Two bullets are fired horizontally and simultaneously towards each other from rooftops of buildings 100 meters apart and of same height with the same velocity. When and where will the two bullets collide? Okay, they're horizontally and simultaneously towards each other. So first we'll look at this phenomena as seen from one bullet. Suppose this is our reference frame. We are seeing this phenomena from A. A is our reference frame now. So according to A, B has no acceleration because both of them will follow the same acceleration g. So as seen from A, B will come straight horizontally. We will not see it fall, right? Relative motion. According to A, B has no acceleration, and according to A, B has velocity 50 meter per second. And they are separated by 100 meter. So B will catch A after 2 seconds, right? So the time taken will be 2 seconds. So after 2 seconds is the correct option. So 1 and 4 might be correct. Now we have to determine the height. So we have to determine after 2 seconds how much height any of them will fall. Let's consider any of them. So the height fall will be half gt square. That is the height fallen. So it is equal to half times 10 times 2 square. That means 20. And the height was 200. So they will collide at a height of 200 minus 20. That means 180 meter. So our correct option is option number 4. Now you are getting after 2 seconds at a height of 180 meter. For the next one, the stress strain curve are drawn for two different materials. It is observed that the ultimate strength point and the fracture point are close to each other for material X but are far apart for material Y. That means X is brittle and Y is ductile, of course. Yeah, first option is correct. For Y, you can yield it, or you can, there may be a severe plastic deformation, but for X it's not possible. It is just break. The rate of radioactive disintegration at an instant for a radioactive sample of half-life is given, that means lambda is given, is 10 to the power 10 inverse second. The number of radioactive atoms in that sample at this instant. Okay, so minus d in dt, that is the rate, is equal to lambda n. So you have to determine n. So n is equal to basically magnitude of this minus d in dt. Minus d in dt is positive, it doesn't bother you, divided by lambda. So lambda is equal to ln 2 by t, and t is given, and minus d in dt is also given. So it is equal to 10 to the power 10 times 2.2 times 10 to the power 9 divided by ln 2. ln 2 by t is lambda. So you are getting it is equal to 3.7 times 10 to the power 19. So correct option is option 3. The time period of a geostationary satellite is 24 hours at a height of 6 times radius of Earth from surface of Earth. The time period of another satellite whose height is 2.5 radius of Earth will be equal to. Okay, so you already know that time period t square proportional to r cube, right? So here we know that t square is proportional to r cube. So now the radius are given. So t square proportional to r cube. So t2 by t1 whole square will be equal to r2 by r1 whole square. Now r2 is equal to 2.5 plus r, that means 3.5. Let's say directly write it 3.5. Don't need this arithmetical calculation to be shown. You already know this. So it is 3.5 r, and at a height 6 re, that means it is 7 r. So cube. Okay. So t2 by t1 whole square is equal to half cube. Okay. And t2 by t1 is equal to half to the power 3 by 2. So you can determine T2 is simply equal to 24, that is T1 24 hours times 1 by 2 root 2, half to the power 3 by 2. Okay, so T2 is equal to 6 root 2 hours. Okay, so correct option is option number 4. A circuit when connected to an AC source of 12 volt gives a current of 0.2 ampere. The same circuit when connected to a DC source of 12 volt gives a current of 0.4 ampere. The circuit is. Okay. So in case of DC, R is equal to 12 by 0.4. So it is 30 ohm. So Z is equal to, in case of DC source, let's say R is equal to 12 by 0.4. That means 30 ohm. Z is equal to, in case of AC, 12 by 0.2. That means 60 ohm. So now let's see what is matching here. X square is equal to the another thing. We don't know whether it is C or L. So X square is equal to 60 square minus 30 square, which is equal to 2700. So X is equal to 30 root 3. Okay. So as in case of DC source, it is giving current. So if capacitor will be there will be no current in case of DC source, right? So this element should be series LR. Okay. So correct option is option number 4. Series LR circuit it is. A cycle wheel of radius 0.5 meter is rotated with constant angular velocity of 10 radian per second in a region of magnetic field of some given magnitude. which is perpendicular to the plane of the wheel. The EMF generated between center and the rim. Okay, so you already know that EMF generated is equal to half omega BL square. L is the distance of that point from center. So it is half times omega is equal to 10. B is equal to 0.1 times 0.5 squared. So it is very easy to calculate, 0.1254. So correct option is option number 1. For a transparent medium, relative permeability and permittivity are given. The velocity of light in that medium will be. Okay. So V is equal to 3 into 10 to the power 8 times the refractive index, which is equal to root under mu r times epsilon r. That means root under 1 times 1.44. So it's equal to 1.44 means it will be 1.2. So it is 2.5 times 10 to the power 8 meter per second. So correct option is option number 4. This option is correct. A sphere encloses an electric dipole. Charge is given. What is the total electric flux across the sphere? Okay, so it's quite easy question. The net charge is 0, of course. It contains an electric dipole, plus q minus q. Doesn't matter what is the amount of charge. So as the net charge enclosed is 0, the total flux across the sphere will be 0, of course. So option number 1 is the correct. Okay, two identical capacitors C1 and C2 of equal capacitance are connected as shown in the circuit. Terminals A and B of the key K are connected to charge capacitor C1 during using battery of EMF V volt. Terminals A and B of the key are connected to charge capacitor C1. So capacitor C1 is getting charged initially. Now disconnecting A and B of the terminals B and C are connected. Due to this, what will be the percentage loss of energy? Okay, they are identical capacitor. Okay, so let's say capacitance is C. So initially the C1 capacitor was completely charged. So here we got charge CV and it got energy U initial, it's half CV squared. Now what is happening when we connect them to the total charge CV will get divided. As they are identical, we can easily say, or it's quite easy to calculate, the charge will be divided in the ratio of capacitance. So this charge will be CV by 2, this charge will be CV by 2. Okay. So the energy stored, now we can determine. So now the potential difference between these two capacitance plates for each of them is equal to V by 2, that is the potential difference. And now the equivalent capacitance between these 2 points to C in parallel, it is equal to 2 times C. So now the final energy we can write down in the form of half Q square by C summation for both, or directly write half C V squared. Now C is equal to 2C, V is equal to V by 2 squared. Clear? So it is equal to half C V square times half. So U final equal to U initial by 2. That means the potential energy has been decreased by half amount, right? So loss of potential energy is 50%. Okay. Okay. There is no more. So this brings us to the discussion of today's paper. Thank you for listening. We are very sorry to provide we are unable to provide you certain exact answer because the question paper print was not available to us. But we have told you the way to do this. I think that will be fine. Okay. Thank you for listening.